The world is a whirlwind of colors, sounds, smells, tastes, and textures. Our senses are constantly bombarded with information. How do we make sense of this chaotic symphony? The answer lies in the remarkable power of perception. Perception is our brain's way of interpreting the raw data from our senses, transforming it into a meaningful and coherent experience of the world around us. It's a process we often take for granted, yet it's fundamental to our very existence. Imagine for a moment trying to navigate the world without the ability to perceive it accurately. Simple tasks like crossing the street or recognizing a friend's face would become insurmountable challenges. Perception is the invisible scaffolding upon which we build our understanding of reality. It's the bridge between the objective world out there and our subjective experience of it. Understanding perception is like unlocking a secret code, revealing the intricate workings of the human mind. By delving into the theories and mechanisms of perception, we gain a profound appreciation for the brain's ability to create order out of chaos. We begin to see the world through new eyes, marveling at the complexity and elegance of this essential cognitive process. How does our brain construct our perception of the world? There are two main approaches, bottom-up and top-down processing. Bottom-up starts with raw sensory data, piecing together individual elements. Top-down uses prior knowledge and expectations to interpret sensory information. Both approaches work together, creating a unified perception. James Gibson proposed a revolutionary idea with his theory of direct perception. He argued that the information available in our environment is rich and detailed enough to allow for direct perception, without the need for complex cognitive processing or inferences. According to Gibson, we perceive the world directly, not through a series of mental representations or interpretations. Gibson emphasized the importance of the environment and our interaction with it. He coined the term affordances to describe the possibilities for action that an object or environment offers. For instance, a chair affords sitting, a handle affords grasping, and a path affords walking. These affordances are perceived directly based on our relationship with the environment. Consider the act of catching a ball. According to Gibson, we don't need to calculate complex trajectories or make predictions about the ball's movement. Instead, we directly perceive the ball's trajectory and our relationship to it, allowing us to move our body in a way that intercepts the ball. Gibson's theory highlights the ecological validity of perception. Perception is not a passive process of receiving information, but an active process of engaging with the world. We perceive the world in terms of our actions and interactions within it, allowing us to navigate and interact with our surroundings effectively. Have you ever wondered how we recognize familiar faces or objects so effortlessly? One way our brain might achieve this is through template matching. Imagine our brain has a vast library of templates, each representing a different object or pattern. When we encounter something in the world, our brain compares it to these stored templates, searching for a match. Think of it like trying to find the matching shape in a child's puzzle. You have a cutout shape, and you try to fit it into different slots until you find the perfect match. Similarly, our brain might compare incoming sensory information to its stored templates until it finds a match, triggering recognition. While this theory offers a simple and intuitive explanation for pattern recognition, it has some limitations. The real world is messy and variable. Objects can appear in different orientations, sizes, and lighting conditions. A rigid template-based system would struggle to cope with this variability. Despite its limitations, template matching might play a role in recognizing highly familiar and standardized objects, like letters or numbers. However, more flexible and adaptable mechanisms are likely involved in recognizing more complex and variable objects. Instead of relying solely on whole templates, our brain might use a more analytical approach, breaking down objects into their constituent features. Feature matching theories propose that we recognize objects by identifying and processing their individual features. These features, such as lines, edges, curves, and corners, act as building blocks of perception. One compelling example of a feature matching theory is Selfridge's pandemonium model. Imagine a chaotic scene with demons shouting and clamoring for attention. In this model, different demons are responsible for detecting specific features. Image demons receive sensory input, Feature demons analyze the image for specific features, cognitive demons represent different objects, and a decision demon listens to the loudest cognitive demon to determine the final perception. This model, though whimsical in its imagery, highlights the hierarchical and parallel nature of feature processing. Different features are processed simultaneously, and this information is integrated to form a coherent perception of the object. Feature matching theories provide a more flexible and robust account of object recognition, allowing for variations in appearance and viewpoint. While bottom-up processes provide the raw materials of sensation, our perception is not simply a passive reflection of the external world. Constructive perception theories emphasize the active role of the brain in shaping and interpreting sensory information. We construct our perception of reality based on a combination of sensory input, prior knowledge, expectations, and context. Think of our brain as a master chef, taking raw ingredients, sensory data, and combining them with spices, sauces, and cooking techniques, prior knowledge, expectations, context, to create a flavorful and satisfying dish, perception. The final product is not just the sum of its parts, it's something altogether more complex and nuanced. This constructive process is evident in various perceptual phenomena, such as illusions, where our brain's interpretations can lead to perceptions that don't match the physical reality. Constructive perception highlights the remarkable flexibility and adaptability of our perceptual systems, allowing us to make sense of ambiguous or incomplete information. The various theories of perception are not mutually exclusive. Instead, they offer complementary perspectives on a complex cognitive process. Our brain likely employs a combination of bottom-up and top-down processing, template matching, feature analysis, and constructive mechanisms to create our rich and dynamic perceptual experience. Imagine a symphony orchestra with different instruments playing distinct but harmonious melodies. The string section might provide the foundation, bottom-up processing, while the brass section adds flourishes and embellishments, top-down processing. The percussion section might provide rhythmic cues, template matching, and the woodwind section might introduce subtle variations. Feature analysis, the conductor, constructive processes, guides the orchestra, shaping the overall sound and interpretation of the musical piece, perception. Similarly, the different theories of perception work together, each contributing to the symphony of our perceptual experience. This interplay of mechanisms allows us to perceive the world with remarkable accuracy, flexibility, and efficiency. Perception is not merely an academic exercise, it's an essential aspect of our daily lives. From the moment we wake up to the time we fall asleep, we're constantly bombarded with sensory information. Our brains seamlessly process this information, allowing us to navigate our surroundings, interact with objects, and make sense of the world around us. Consider the simple act of walking down a busy street. Our eyes take in a stream of visual information, the movement of people, cars, and bicycles, the colors and shapes of buildings and signs, the changing patterns of light and shadow. Our ears register the sounds of traffic, conversations, and music. Our sense of touch tells us about the texture of the ground beneath our feet and the temperature of the air. Our brains effortlessly integrate this sensory information, allowing us to avoid obstacles, recognize familiar faces, and navigate our way through the urban jungle. This constant stream of perception guides our actions, shapes our decisions, and enriches our experience of the world. The study of perception is an ongoing journey of discovery. Researchers continue to unravel the mysteries of how our brains transform sensory input into meaningful experiences. New technologies and research methods are providing unprecedented insights into the neural mechanisms underlying perception. As we delve deeper into the brain, we're likely to uncover even more sophisticated and nuanced mechanisms of perception. The boundaries between bottom-up and top-down processing might blur further as we discover how intricately interconnected these processes are. We might find that our current theories are merely stepping stones to a more complete and integrated understanding of perception. The journey of understanding perception is a testament to the remarkable capabilities of the human brain. It's a journey that takes us to the heart of what it means to be human, revealing the intricate processes that connect us to the world around us. As we continue to explore the inner workings of the brain, we're bound to uncover even more astonishing secrets about the magic trick of perception. Enjoyed the video? Stay curious, Subscribe for more psychology insights. Tap the bell for updates. Like and share if you found this helpful. Keep exploring the mind with us.